We are live, guys.
Okay. Camera for action.
Okay.
Not that bad.
All right. So we're moving on. So we're moving on. We have pretty much talked about systems of equations, and I think you guys know those relatively well. Solving them by graphing, where do they cross, right? Solving them by substitution. You guys remember all this stuff? And then solving them by elimination, right? And manipulating the equation so that they eliminate one of the variables, right? And I think you guys are pretty good at those. We'll come back to them at some point and do some more word problems so that I'm sure you sort of see how they work in real life. They are very useful in real life, very useful. A lot of times, like if you're trying to figure out which cell phone plan is cheaper, it's a great, using systems of equations will tell you within minutes which one is the better plan for you, you know what I mean? Now, they hope you don't know the systems of equations, approach, because they want to fool you. And they want to, but if you, they have all their little spiel. And each one sounds like a good deal. And each one is a very different deal. Sometimes they're very similar, sometimes they're very different. And they don't want you to know how different, right? Because they wanted to make those extra $20 on you. So we're going to talk about exponents and exponent rules, and it's a big subject, actually. There's a lot to exponents. How many people know what exponents are, first of all?
Me.
Okay, has everybody been exposed to them? They should be.
Yeah.
Have you been exposed to them? You have? Okay. All right. So let's first be sure everybody's on the same page and we understand what exponents are. So if I had 2 to the 4th power, that would equal 8, right?
No.
No?
It'd be 2 multiplied by itself 4 times.
Don't worry, Gary, I do that.
Okay.
That's what I do.
You're right. Okay. So we just learned a rule. There's this very important rule. And this is the rule.
Never, ever, ever eat
Ever.
soggy waffles.
Ever. Just say.
Oh my goodness! Never, ever, multiply by the multiply not by the derp exponent by the derp space.
All right? Or the other way around, however you want to write it. Don't ever, wait, what is the base?
The big number.
The full big number. The one that's lower.
Yes, the base is the 2. In this case, this is the base. That's called the base. B-A-S-E. Right? What is this called? What is that called? The exponent. Is there another word that some people use? The exponent or power, right?
Oh.
Right? You got the power, right?
Power.
The 2 has the power of 4,
I have a
right?
song for everything.
Right?
I know.
So that's real important because we're going to be talking about this a lot today, about the base and the exponent, because we're going to be doing more than just having a base and exponent. We're going to take a base and exponent, we're going to multiply it by another base and another exponent, and that times another base and another exponent. And we got to figure out how we can combine them together, okay? So it's real important that you understand that the exponent, you never multiply that times the base. Never, ever, ever, ever. No exception, never, ever, okay?
Never ever.
And all the exponent does is tell you how many times you multiply 2 times itself, right? The base times itself. Here. So that's the only thing that the exponent tells you, is the number of times you multiply the base times itself, right? Okay, so what we're going to do now is we are going to, since we have that down, we are going to look at the very first exponent rule, okay? The absolute first one. It's the easiest one. And it's written in a weird fashion. It says like let me think here. A to the m times a to the n is equal to a to the m plus n. Okay, so write that down. What?
What?
Write that down. That is rule number one. Rule
What's it like?
number one.
Put together.
So just write that down for a second. We're going to talk about this. So if I have, this is an example now. Example, we'll just write 1. If I have x to the 4th times x to the 5th, what would that equal? X to the m plus n. This exponent times this exponent, plus this exponent. So 4 plus 5 is 9. Now this is a shortcut. This is an algebraic shortcut. Algebra, I don't know if anybody's ever told you this, but algebra is all about shortcuts. All about shortcuts, right? And so if I did that the long way, let's just see how we do it the long way, okay? And you'll see why it's great that we have a thing called algebra. It's awesome. So what is x to the 4th? Let's do that one. Let's write that the long way.
X times x times x times x.
Okay. All right. So that's this, right? That is this. Right? What is x to the 5th?
X times x times x times x times x.
Times x times x times x times x, right? That's that. Okay. So how many x's do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So that would, then we could say, well, that's x to the 9th power. But look at this shortcut that we did. As long as the bases are exactly the same. This is the one key you have to see. It says a to the m times a to the n. The bases are a, right? They're the same number. They have to be the same number in order to use this rule. The bases have to be the same. So what if I gave you this? What if I gave you something hard like this? X plus 5 squared times x plus 5 to the 9th. What would that equal?
X plus 5 to the 11th power.
So, do we have same bases?
Yeah.
Yeah, the blob here is the same base. The x plus 5 and the x plus 5, right? So I'll just keep it in my parentheses, right? And then same bases, that means I can add, I'm multiplying them. So I'm multiplying same bases with exponents. I'm going to add the exponents. So it's going to be to the 11th power, right?
Yep. Oh god.
Right? Makes sense, right? It's pretty easy, really. It's really pretty easy.
Please tell me that x equals 0. Then it would just be 11. And then it would just be 55. No.
How would you end
Five
up?
times five times
Never,
five times
ever,
five times
ever,
five
ever,
times
ever.
five times five
If you make x equal 0.
I don't want to figure out what 5 to the 11th power is.
Let me see.
I would take the rest of the class.
Don't erase it.
Well, it would
Oh,
be a
don't erase
lot
it.
easier if
Quickly
you
take the
didn't
picture.
add it, so it
That would
would
be
be 1.
Well, this was another example. That was example two.
Wait, I'm just going to something.
And let's do another one. Let's just do a few more examples.
I can't do that.
Times 5 is 100.
All right. Now, what about this, guys? What if I did this? Negative 6 to the 7th power times negative 6 to the 4th power. What would that give me? Same bases with exponents, and I'm multiplying. Yes.
Negative 64.
Negative 6. I keep the base the same, don't I? And then to the 11th power. Now, do I know what am I doing? Stepping on all the homework.
Oh, Gary,
For shame!
we worked
I
hard
see
on
mine.
that.
Take that, you homework. Okay.
Evil
Kill it.
Algebra.
Kill it.
Burn it.
So notice we kept the base exactly the same, right? Now, could I go a step further? Could I simplify this a step further? Do I know?
Yeah.
Is that going to be a negative or a positive number?
Negative.
How do do you know? How do you know?
It's an odd number.
No, it's gonna be
It's
a
an
positive
even
number. It's gonna be positive.
If so this is important to understand. If the exponent is an even number, remember negative. An example of even would be negative times negative is a positive. All right. Another negative times negative. If I had 4 negatives, right? I mean, if I had an exponent of 4, it'd be negative times negative, which is positive, times negative, which is negative, times negative, which is positive. So whenever the exponent is even, and it's affecting, it's important, it's got to be affecting that negative sign. How do I know it's affecting that negative sign? It's next to a parenthesis, and the negative sign is inside the parenthesis, right?
So if it's an odd exponent with a negative number, it'll be positive or negative?
It would be negative. So if the exponent, right, if, okay, we'll just say if base is negative, right? If base is negative, and exponent is even, then answer is positive, right?
Wait, do you mean
In other words, if the exponent is positive, it's going to be positive. If exponent is negative, it's going to be, what am I saying? If exponent, I'm not thinking. If exponent is even, it's going to be positive. If exponent is odd, it's going to be negative. That's assuming your base is negative, if your base is negative, right? So is that going to be positive or negative?
Negative.
So I could actually just write it like this if I wanted to. I could say negative 6 to the 11th power. That would be the same thing. Because, think about it, that 11 now is not affecting the negative. Because the 11, the exponent only affects what it's next to. You guys see that? This is probably one of the biggest places where people get confused in exponents. Because this and this, yes, they equal the same thing, but if I had put a 2 there, a 12 there, and a 12 there, they would be wrong. This would be wrong.
Wait, I have a question.
This, let me just show you this. Negative 6 to the 12th power does not equal negative 6 to the 12th power. Why?
It equals positive 6.
It equals, this equals positive 6. Because here, the exponent affects, it actually affects the negative. It's negative 6 times 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 negative 6. You see that? And because that's an odd exponent, it's going to eventually end on negative. So I can still write negative 6 without the parentheses, and have the 11th power, because it will be negative 6 to the 11th, right? Which, this is not negative 6 times negative 6 times negative. This is negative 6 times 6 times 6 times 6 times 6 times 6 times 6. Do you see the difference? Right?
Yeah.
The 11 is only next to the 6, not the negative. So this only affects the 6. The negative is completely out on its own, and it stays. It never changes. If I had negative 6 to the 12th power, it would still be negative 6 to the 12th power. But look at this one. Here, I've got negative 6. The negative 6 is inside the parentheses. The exponent is next to the parentheses, right? Therefore, that exponent affects everything inside the parentheses. So it's negative 6 times 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 negative 6 times, right? All the way till you get 12 times, right? And 12 times is an even number. Therefore, that's going to become a positive 6. Does that make sense? It's going to be a positive answer. So I could say that it is the same as that. Does that make sense? Do you see that? Am I losing you guys? Does it make sense, Gideon?
Yeah.
You got it? Okay, awesome. Very good. That's awesome. So that, okay. All right. I am going to erase this, okay?
No, you're not.
Sorry. Go ahead.
No.
Take your picture.
Jump to the thing.
No, it's called having a lot of
Smile. I'm not, it's
I
not.
have the same homework as you do.
Rawr.
Yeah, but I also have a life.
You got it?
Yeah.
Okay, good. All right, now we're going to erase all this stuff. Hi, how are you? All right, I'm going to keep our rule, but I want to show a few more examples. Okay? So that, what did we finish? What was the example? 3? 3? Okay, we'll do 4 now. So 4. What if I mess things up a little bit? What if I said this? 2x to the 3rd power times 4x to the 5th power.
No.
Ooh.
They're not like terms.
They are not like terms. She's right. They're not like terms. But what about the bases? Let's think about what we know. We know there's wait, let's raise your hands. Yes, Cassie. Say again?
It's only affecting the x's.
It's only what?
Affecting x's.
Yes. The exponent is only affecting the x's. It is not affecting the 2. Does that make sense? This does not mean 2x times 2x times 2x. That's not what that says. This says 2 times x times x times x, right? That's what that says, right? So, and what is that? What are the properties of algebra that says it's okay to move things around?
Distributive. No, what is it?
I never got
What is it? What is it with when if your dad works at Los Alamos, right? What does he have to do every day in the morning? He jumps in his car and he
Drinks coffee.
commutes, right? What did you say?
Drinks coffee.
Commutative property, exactly. The commutative property of algebra, yes. Commutative, commutative, property. Sorry, I'm writing fast. Commutative property says it's okay if you're multiplying or adding, they can be any direction, right? I can move things around as long as I don't know, I can just move things around. As long as I can just change places. So look, what I could do, according to the commutative property of multiplication, would you agree with me this is 2 times x cubed times 4 times x to the 5th? Yes? Then can I move the 2 and the 4?
Yeah.
Put it in a different place? Could I do it this way? Could I write 2 times 4 times x cubed times x to the 5th? Could I do that? Is that legal?
You can even simplify it further and combine the x's since it's the same base.
Oh my gosh! Brilliant! Brilliant, young man. Brilliant. Okay, so let's go from left to right and see what we can do. Can we simplify 2 times 4?
Yeah.
8. Oh my gosh, that's great. 8. Can we simplify x cubed times x to the 5th? Do I have same bases? So it's x to the 8th. Oh, I'm starting to see patterns. The number in front of the x must always equal the exponent. You're right. No, that's wrong. Okay, good. I just want to be sure you guys are awake. All right. How about, let me think. Let me look at, let's try another one. 5. Let's try,
Wait, Gary, how would you solve it when it has, when x isn't solved?
It'd be x equals, or no, because it doesn't have an equal sign.
well, yeah, you can't solve this because there is no equal sign. If I said equals 0, then I could say x is 0. I would be able to solve it.
Oh, then the answer would just be 0.
X would equal 0. But there's no equal sign, right?
No, but I mean then the answer would equal 0 no matter what, because anything times 0
Right.
equals 0.
Yes, exactly. Right. So, what if I gave you this? 2x times 3x to the 4th times 4x to the 5th.
Dang.
Can I use the commutative property of algebra? So I could say 2 times 3 times 4 times x to the 4th times x to the 5th, right? So what is this? 2 times 3 is, times 4 is,
24.
so that's 24. What is this?
To the
21.
ninth power.
X to the 9th power?
Yes.
X to the 10th.
But there's no exponent on this one.
There is. Well, you write 1 in.
Oh yeah.
It's the same thing.
Wait, are you telling me that there is an exponent on this one?
Yeah.
Yeah.
But it's nothing. I don't see anything. It must be
It's
a
in
0.
It's just like how x has a hidden value of 1 when it's by itself. It has a hidden exponent value of 1 because otherwise it wouldn't exist.
God, I'm glad you guys are keeping me. God, you're telling me there's a 1 exponent there?
Hidden
Yeah.
You're right. That's awesome. Okay, so what do I have? I have x to the 10th. Right. Beautiful. Well done. Good job. Okay, what if I gave you this? 5, 6. Where's the new? Another problem. Sorry. What if I gave you this? X to the 4 times x to the negative 5th times x to the 6th. What would that be?
Okay, so would it be, I don't know.
4 times x to the next. Gary.
No.
Gary.
No, Gary.
So
Gary.
personally, I find it easiest to add the 2 positive ones first.
Yeah.
6 plus 4 is 10, minus 5 is 5, right? And so it's x to the 5th power, right? You guys all understand this? And
Yeah.
you see how that is using this rule? You
It's
see
like
I'm using the rule?
it's kind of like
Integers.
Okay.
I'm a vinegar.
Now, I want you to tell me, what is the value of this? What is that equal?
that would equal.
Okay, hang on one second, because I started this. What does that equal? Number 6.
Negative 16.
Positive.
Negative 16.
It has to be a positive.
No, it's negative.
It's 16.
It's
Alright.
a negative.
It's 6.
It's negative 16.
Alright, how many people, alright,
I
so,
don't care.
so 16 seems to be a fairly common thing I'm hearing, right? But I'm hearing some negatives and some positives. How many people think it's negative 16? Raise your hand. 1, 2. How many people think it's positive 16? Raise your hand. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my gosh. Alright, so never go with the crowd. I'm just going to give you a hint. Never go with the crowd.
What? I didn't.
Okay, what is the 4, the exponent
It's
affects?
positive.
What does it affect? It affects what it's next to. It does not affect the negative sign in this case, right? So that means it's going to be negative 2 times 2
it has
times
to
2
be in
times 2,
parentheses.
which is negative 16, right? Now, had I said this, negative 2 to the 4th power,
Oh, that's the
then it
parentheses.
would be
Okay.
positive 16.
Yes.
It would be positive 16.
Yes.
So, Gideon, you may stand up and take a bow. Okay, good. And you too, Mira. You too.
Wow.
What?
Happy birthday, universe.
Thank you, universe. I'm finally right. Here, let's speak of me, a unicorn.
No, but tomorrow.
Ah, okay. Now, let me erase this. Can I erase?
I'm a unicorn. I'm a unicorn. I'm a dead unicorn.
What time is it? Okay, what's up?
You're a unicorn without magic.
Wait, Gary.
Okay. What if I gave you this? What number are we on?
8. Or 9.
9.
Nine.
Oh, yeah.
All right. Guys, what if I gave you this? X
Wait,
squared
did you let Mike take a picture?
times
Oh my
y.
God, you guys don't pay attention. Gary,
Okay.
Mike didn't take a picture. He asked me if you could
Oh,
erase it.
okay.
I said yes.
Yes, I did ask
Dear
you.
God.
It's X,
Okay.
Y
We don't
to
pay
6
attention,
power.
do we?
I do.
Okay, so guys, here we go. All right, what's the answer?
Here.
X, Y to 6
X,
power.
Y to the sixth, yeah, that.
Okay,
No.
Oh, that's like, well,
wait,
yeah,
wait. Look at our rule though. Just look at our rule for a second.
They're not the same.
What's not the same?
The base.
The bases are not the same. So if they're not the same, what do you do?
You can't add them.
since they don't have a known value right now, you can't do anything.
So I'm gonna give you the answer. I have to do a quick calculation. Hang on. Okay, here's the answer.
What is
Oh.
that?
Oh!
Oh! I did that in my head, you guys. That's impressive.
It is.
Isn't that awesome?
Knowing you?
Right? So
I'm joking.
the rule says the bases have to be the same, right? In order to add the exponents. If the bases are different, I can't add them. I have to keep them separate. Now what if I did this? 10. What if I did this?
Give us real numbers.
3x to the 15th times
Holy cow.
4y to the 12th.
It's in high school.
What would that be?
Just shove them together.
3x to the 15th, 4y to the 12th.
Yeah, that. Take the whole
Can
side.
you, wait a minute, can you use commutative property?
Yeah. No.
Yeah.
Commutative property of multiplication. Yes. So I can move the 4 over here, right? I could say 3 times 4 times x to the 15th, y to the 12th. So my answer would be 12. At least I simplified something, right? But then I still have to keep my x to the 15th, y to the 12th separate because they're not the same bases, right? Right? If I did this the long way, right? Think about what that would be the long way. It would be x times y times y times y times y. It would be x squared, y to the 4th, right? You can't combine them, other than keep them there. Okay, well, let's see. I think there's one more.
It's 10:03.
10:03. Great.
What if I did this?
35 minutes.
What would that be?
Oh, wait.
Never,
6x.
ever, 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 ever.
8x.
It would be 2 times 2 times 2, which is 8.
Oh yeah, 8x.
8x. Is that right? Is that right?
Yeah.
Yeah, that's
Yeah,
right.
that's right, man.
Right. Just remember, this means 2x times 2x times 2x. Okay? All right. I think that's all I'm going to give you. So yeah. All right. So that's it.